Smart Internet Lab has built a strong research relationship with a leading European research organization and also European industry in 5G area. The Smart Internet Lab has pioneered advanced technology for orchestration of the 5G technologies. That includes deployment of and development of the new AI and machine learning basic technique for orchestration, as well as new type of the edge computing. This capability allows to 5G applications and verticals to run at very low latency and with a very high bandwidth that they need for their services. So we use this application to basically showcase that how 5G Victori can support new type of the verticals in this research project.
The vision of 5G Victori was to actually create a 5G platform which is able to support a wealth of fixed and mobile services for the telecom and vertical industries such as, for example, transportation, energy, media, etc. So what we tried to do with 5G Victori was to actually create an integrated infrastructure that brings together 5G infrastructures that were traditionally isolated and purposely developed, create an open ecosystem and give the ability to players to create their own services using the common underlying resources and functions, creating common repositories. This will give players the ability to offer and support their own services with improved performance and increase the cost and energy efficiency.
We focus on the digital mobility use case, Mativision providing application 1 and 2, and Urban Hawk provide application 3. I2K, Digital Catapult and Zeetta Networks, they are integrating their equipment and facilities into the 5G UK test network. We use machine learning techniques to profile the network services to meet the KPI. 5G BIOS use these resources to assign to the network services.
Here at the University of Bristol, we have a private cellular network in an urban area like this space. From MShed and really curious, we provide transmitters under the shared spectrum to provide services on a private cellular network. This private cellular network is used for the testbed, in this instance as 5G Victori Project use case demonstration. Here we are for the first time using our private cellular network in a maritime environment where we demonstrate handover of services from one private network to another, seamlessly providing a service to tourism or various other industries that could support it.
Here in the University of Bristol 5G UK test network, we provide wide range of facilities to support research projects. One of these facilities is cloud infrastructure virtualization solutions, which we call it Cloud Plus. This is a multi-tenant MEC-enabled solution to support different types of virtual functions like VMs and CFs. In this specific project, the 5G Victori, we are using this facility to host the project entities in our cloud in different edges and provides the end-to-end connectivity between the end users and the cloud entities. We provide a wide range of monitoring tools for different research projects. This is an end-to-end monitoring solution to monitor the cloud infrastructure, the network side, as well as the UIs. For the 5G Victori project, we extend and develop the probes for the UIs to somehow monitor the radio parameters of the UIs, such as RSRP, RSRQ, no signal-to-noise ratio, and reports them to the edge monitoring for further analysis.
The CPE is actually a small computer with a 5G modem attached to it. The pneumatic node is a 5G in a box actually, from the 5G network to the edge computing capability to the core packet switching. Everything is included in one box, along with other technologies such as Wi-Fi. The main challenges of the 5G Victori project was actually the integration of a diversity of technologies and the vendors into one box, into one network.
We have been supporting 5G Victori with two key contributions. The first is the development of 5G Victori infrastructure operating system, or otherwise known as 5G BIOS, which is an interdomain orchestration platform to manage the experiments and the services across different facilities and domains. and also supporting this experiment here in Bristol with our nomadic node, the Amarisoft box, basically offering 5G NR capability on the move now while we are on the boat.
In this project, our main contribution has been the slice manager and the run controller, which are solutions that are able to configure, operate and monitor radio and network resources in order to create on-demand tailored run slices. So in particular, in this trial, we have integrated these solutions with the 5G OK and the 5G BIOS solutions in order to deploy a multi-RAT slice.
On the 5G Victori project, we've used our software, Zeetta Automate, to manage the network slices. To do that, we're configuring the different devices on various different locations. So our software is used to configure the VLANs on the switches on each location.
Mativision is involved in the 5G Victori project as a specialist in 360-degree video and immersive technologies. So what we aim to do here, we have two different use cases, and we aim to demonstrate the performance and the capabilities of the 5G network in delivering immersive content. So the first case is an application in which we will deliver immersive, informative content to travelers across the city center, also involving mobility, moving objects like a ship, on which we are today. And the second case is recreating a virtual classroom in which we will aim to deliver live lectures from one location to remote locations, even in different cities.
5G gives us the ability to pull in real-time data and provide an accurate simulation down to 1 meter scale. That can be across the entire of the UK and indeed into Europe. We can then take a traveller or someone that's visiting a new location and navigate them and use actual data from real sensors to drive that.